Hello everyone. In this video we are going to discuss about postfix evaluation. These are the contents of this video. First we will discuss about what is the actually postfix, and then why postfix evaluation is required, and one example and implementation of this postfix expression in C language. Right? Okay. So first, what is postfix expression? Simple. There are three types of notations you can use for the arithmetic expression, like your first infix notation, postfix notation, and prefix notation. Okay. So if the operator is placed after the two operands, then expression is a postfix expression. For example, suppose there are two operands, first A plus B. Right. See, this is operand, and this is operator. Right? This is operator. Okay. So whenever operator is placed between the two operands, then this is infix notation. This expression is infix notation. And whenever operator placed after the operands, then this is postfix expression. And whenever operator is placed before the two operands, this is prefix expression, as you know already. Now the question is, why we are going to study this topic, postfix expression, right? For this, let me take one example, and after that I will discuss why postfix expression is required, why not, what is the problem in infix notation. As you know from schooling, we generally use arithmetic expression like 3 plus 5 into 6, like this. Okay, so why this is infix expression? Because the operator comes between the two operands, right? But what is the problem in infix notation? Why we are going to study about postfix expression in terms of computer, right? So we will discuss later after the completion of this example. Okay. For the sake of simplicity, for the sake of understanding, I am taking the first example. Then I will try to explain why postfix expression is required. Okay. Let's take this postfix expression and evaluate. Okay. So for this, we have to use this 4-column table. First, we have to write symbol, and next one is operand, operand 2, and operand stack. Right. So we have to scan each and every symbol from left to right. Right. I'm going to take first symbol. This is 2. I'm going to write here 2. Right. And I'm going to push in the stack. This is 2. Okay. Now, okay. Let me solve this postfix expression using stack. Okay. Suppose I'm going to take this one. For example, 2 3 plus plus 8 2 3 divide power divide minus, right? Suppose I am going to solve using this stack and scan symbol from left to right. Okay, the first is operand, just I am going to push in stack. Now second symbol is operand, now I am going to push in stack. Third symbol is what? Operand. Now I am going to push in stack. Now whenever operator is coming, now I have to pop two items from the stack one by one. Okay. Now I am going to take 5 and 3, and 5 into 3, that is 15, and now I am going to give here push 15. Okay. Now whenever plus is coming, then two operands will pop from the stack and evaluate. So 15 plus 2, what should be? 15 plus 2 is 17. So I will write here 17. Right. Similarly, 8 is coming. Now I will push 8. Now 2 is coming. I will push 2. Now 3 is coming. Scanning. So I am going to push this 3. Now what is? Divide is coming. This is power is coming. So now listen carefully. Whenever the first operator is coming, so whenever operator is coming, I have to pop two items from this stack one by one. Now listen. First I am going to pop this element 3 and I will keep in variable 3 y, and this 2 will keep in variable x. Now listen carefully. Now I am going to operand. Now I am going to apply x power y. Listen carefully. This is very important. X power y means x power y. This, listen. Don't get mistake. Not 3 by 3 power 2. This is 2 by 2 power 3. So I have to write 2 power 3. This is 8. Okay. So x power y, not y power x. So this is difference. Now next is divide operator is coming. 8 divided by 8. 8 divided by 8. This is 8 divided by 8. This is 1. Now minus is coming. Minus means 17 minus 1. Not 1 minus 17. 17 minus 1, that is 16. The answer is 16. Okay. So this is using stack operation, but I am going to use tabular method for evaluating this postfix expression. Now first symbol is coming 2. I will push in stack like this one. I will push in stack. Now next symbol is coming scanning. This is 3. Now I will push in stack 2 comma 3. Just comma is taking as a separator. Okay. So a question may be asked in examination 2, 3, 5. So just you consider this, each and every symbol is individual, like 2 comma 3, not 35, not 23, 2 comma 3 comma 5. Okay. So I am scanning this symbol from left to right. 2 I pushed in stack, 3 I pushed in stack, 2 comma 3. Now 5 is scanning. 5. So what should I do? 2 comma 3 comma 5. Now operator is scanned. Whenever operator is scanned, then I have to pop 2 items from this stack. I will keep in this column. First 3 and this is 5. Actually there is no need of this 2 column, operand 1, operand 2. But sake of understanding, sake of simplicity, I use this operand, this column. Because you will just pop this element and keep in this column, and easily you can evaluate. Now 3 into 5. 3 into 5 is 15, and now 3 and 5 already popped. So I am going to write in place of 3, 5 is 15. Right. Now next symbol is scan, that is plus. Now operator is coming. I will pop two item from stack one by one, and now I keep in this 2 column operand 1 and operand 2. Okay. Now addition 2 plus 15. The 2 plus 15 is equal to 17. Okay. Now next 8 is coming. 8 is scanned. 8 only 8 is scanned. Now this is not operator, so I will push in stack. Okay. Now next 2 is scanned. This is operand, not as operator. Just I push in stack. Okay. Now next is 3. 3 is operand, not as operator. Then only I will push in stack 2 comma 3. Right. Now power is coming. This power is an operator, so I will pop two element from stack and keep in this table. This is column 1 and column 2. Now listen carefully. 2 power 3, not 3 power 2. Very important line. 2 power 3, not 3 power 2. So that's why I am taking this operand 1 and operand 2. Just simplicity. For the sake of simplicity, I will just copy this 2 and 3. Just I am going to put 2, 3. This is 2, 3 and this is 2, 3. Right. The 2 power 3 is 8. So I am going to write here 17, 8, and at the place of 2, 3 I am going to write 8. Okay. Now divide is scanned. This is operator. I will pop this two elements 8, 8. 8 divided by 8, and this is 1. Okay. Now last symbol is scan minus. This is operator. I will pop this 2 element 17, 1. The 17 minus 1, not 1 minus 17. Remember 17 minus 1, this is 16. Then answer is 16. Right. Okay. So how can you verify this answer, whether my answer is correct or not? See, so this expression is postfix expression. Now the shortcut is you just convert this postfix expression in corresponding infix expression, and when you convert this expression in infix expression, then you apply BODMAS formula, apply BODMAS techniques and solve. Then definitely you will get the 16 as your answer. Then you can verify your answer. One question may be asked like this: is this postfix expression is valid? How can you verify your expression is valid? Okay, so for this, one thing I would like to say here: how many symbols are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 symbols are there. 11 divided by 2. Okay, I am going to take the seal of 11 by 2. The answer is 11 divided by 2 means 5.5 is equal to 6. Okay, this is number of operands. Number of operands. Okay, and for the operator, number of symbol is equal to 11 divided by 2, and I am going to take the seal value, floor value. The floor value is equal to 5. Okay, 11 divided by 2 means 5.5, and 5.5, the floor value of 5.5 is equal to 5. Okay, so this is number of operators, right? Where 11 is what? N. So you can say, if in expression, postfix expression, if there is n symbols, then seal value of n by 2 must be number of operands, and floor value of n by 2 must be number of operators. Then that postfix expression is valid expression. Okay, for example, suppose I am going to take this one: 2, 3, 5, plus. Okay, is this valid expression? No, because there is the 4 symbol, and 4 divided by 2. 4 divided by 2 means there are 2 what? In case of seal, number of operand is equal to 2. That number of operand is equal to 3. So this is not valid postfix expression. Okay, see. Okay, one thing. Now another thing is, one question will be asked: what is the size of a stack? 1, 2, 3, 4. So the size of a stack is equal to 4, and you can verify also. This is the size of a stack is equal to 4. Okay, the size of a stack question will be asked, and whether your expression is valid or not. The same logic we will apply in coding part also. So what we will do in coding part? Listen, I will take this postfix expression as a string. Okay, you can do also. You can append as a special symbol, like you can append like hash. Okay, in starting and ending. For this key, your string is ended. Okay, so you can use any symbol, and symbol. Okay, for this you can understand. You can check whether my string is over or not. Okay, but in programming point of view, already null character is there. Okay, but theory mein you can use a special symbol that like hash or any other symbols. Okay, so in programming, I will take this expression as a string. I will scan this string from left to right. Okay, and whenever operands are coming, then I will push in stack, and whenever operator will come, then I will pop 2 elements and store in variable x and y, and apply the particular operations according to the operators scanned. Okay, so this is very easy coding also. After evaluating the postfix expression, let's discuss why postfix expression is required. Okay, the first reason is actually, if you enter any infix expression to computer, then computer will first convert that infix expression in corresponding postfix expression, then evaluate that. Okay, so now problem is why computer do like this. Suppose I am giving you infix expression, like where suppose I am going to give you 2 plus 3 into 5. Okay, see, the first you think which operator is higher precedence, plus or star. You found that according to BODMAS concept, BODMAS concept, this star is higher precedence over this plus. Okay, so first you evaluate 3 into 5, 15, and then 2 plus 15 is equal to 17. We will give the answer. But for the computer, this is not an easy task. Okay, this is the additional complexity of handling the precedence, right? So remember this point, computer directly not evaluate your postfix expression. First infix to postfix, then postfix evaluation. Then in that case we should know about postfix evaluation. Infix expression are not used for implementation of expression inside computer, okay, due to the additional complexity of handling. What is the additional complexity? This is additional complexity, right? What is the additional? Computer has to decide which operator is higher precedence. So taking decision is the additional complexity of handling the precedence, okay, right? And another point is prefix and postfix expression is free from any precedence. You know already. In previous example, you can easily understand we are just moving left to right. Okay, just moving left to right. No decision taking. No decision whether this operator is higher precedence or not. Just I am moving left to right, scanning each and every symbol and just comparing whether this is operator or operand. If operand is coming, just push in stack. If operator is coming, then evaluate only 2 symbols, 2 items from stack. That's very easy process, left to right. That's why computer uses postfix form for representing an expression. Remember this point. So due to this reason, due to additional complexity of handling the precedence, we generally computer used what? Postfix expression. Come to the implementation of postfix evaluation. Now come to the coding part. Now I am going to take this postfix expression as a string of maximum 50 length. Okay, and now what is this? This is the I variable for the indexing and top variable for the stack. Okay, suppose top is equal to -1. I am going to write here top is equal to -1. And n is the for the length of a string, okay, and x and y, x and y for storing the top 2 elements from the top of the stack, as we discussed in theory part, okay. And this is stack 50. Stack is the maximum size of a stack is 50, and that will use to push all the operands accordingly, right? So this is the string scanning, line number 8 and 9. Line number 10 getting the length of a string, and now we are going to take the for loop. Okay, for loop is 0 to length of a string. Okay, now just I am going to take the str0, I is equal to 0, str0 is what? 2. I will match this 2 with cases. So this is first case plus, and here is the 2 plus no match, and minus no match, and star is no match, and divide is no match. Okay, so definitely default case will execute. In default case, top is equal to top plus 1. So now I am going to increment by 1. Now the top is equal to top plus 1, minus 1 plus 1 is equal to 0. It means top is indicating at this point. This is index 0, 1, 2, 3. This is the index of this is stack. Okay, now what line number 46? Line number 46 is doing what is? It is converting, like it is checking whether this scan symbol is integer or not. Okay, and now line number 47 is converting character symbol to integer value. Now let's see how. Just a minute. Let's see how. Okay, you know, for example, suppose capital A sky value of capital A is 65 and small a is 97, and you know a sky value of 0 is equal to 48. Remember this one. A sky value of 1 is 49, and you can write like this: 0 is the character, 1 is the character. A sky value of 2 character is 50. Okay, now listen. So this line number 47 is actually converting character to integer. So what is stri? I is equal to 0, I is equal to 0, str2 is 2, and this is character. So what is the ASCII value of 2? That is 50, and 50 minus 48 is 2. Now x2 is assigned to the variable x, and now that x is going to store at the top of the stack. So this I will going to push the stack in stack. Okay, now x is equal to 0. I will refresh each and every time x is equal to 0, because here x is assigned x divided by 2, x is equal to x into y. So from each and every symbol we have to refresh the value of x at 0. Okay, now so this is the process of now come to this one. Now 3 again, 3 will come and match with default case, and in that case, let me change the color. That case 3, so 3 is, what is the ASCII value of 3? 51. So 51 minus 48, that is 3, the x is 3, and top is equal to top plus 1. Now top is equal to top plus 1 means 1. Now top pointing to this position, and I will keep here 3. Okay, similarly 5 will come here. Now whenever operator is coming, now see what about the operators. When our operator is coming, where is the operator? Star. Okay, whenever match with star, then case plus case star, and what is this? And case, this is case star. You see line number 30. In line number 30, what actually doing? Y stack top. What is the top of the stack? What is the top of the stack is 5. Let me choose the pencil. What is the top of the stack? That is 5. So now I am going to assign in y5. And what is the stack top minus 1? 3. So this is going to assign in x. Now top is equal to top minus 1. Now top is going at 0. Okay. Now, and at the time of 5, stack is already the top value will be 2. Now decrement by 1, that will 1. Okay, now x is equal to x into y. Remember this one. So 3 into 5 is equal to 15, and that 15 is going to store at the top of the stack. So that will store at the top of the stack, that is 15, and already the value of top is equal to 1. So at the 1, 15 will be stored. Okay, now the break statement. Now for the next operator, again we will check. Okay, similarly, so now this is the important. Remember one point I would like to remind here. Simple. See, in case of divide, x divide by y. Okay, not y divide by x. Okay, remember this point. Okay, this is the, now let me execute this code and see what is the output. Okay, I am going to enter the valid expression. Suppose I am going to write here 2 3 star plus. Okay, so what should be the output? 2 3 5. Suppose 2 3 5 star plus. So what should be the output of this one? So 2 3 star plus 1. 3 5 is 15 plus 2. 3 5 is 15 plus 2, 17. So answer is, the value of postfix expression is 17. Okay, that's very easy. You can write your own code of this postfix expression also. That's very easy logic. Okay, hope this program is clear to you, and evaluation of postfix expression also. Okay, thank you for watching.